Alright, let's continue today example 3 for curve sketching. Let's take a look at this example. Y equal to the x to the power of 2/3 multiplied by x plus 2. Now this is not easy function for sketching curve, because we know only about when x equal to 0, y equal to 0, nothing else. So sketch this curve by using differentiation, by using derivatives, is very, very essential, very, very crucial, very practical, very, very important. Okay, now to save your time, let me write down the derivatives, because I don't want to go detail of the derivatives. This is equal to 1/3 x to the 5 plus 4x. Okay. Well, of course, this is an easy function for differentiation using product rule, right? Or you can multiply them in to find the derivatives separately, and you simplify to this form. Why we need to simplify this form? Because from this form we can easily find what is the value of x when derivative equals 0. Why we need derivative equals 0? Because we need to find the maximum minimum points. Now, alright, so let's see. This one equal to 0 implies x equal to 0, right? And this equal to 0. So what is this? So x equal to what? 5 plus 4 of x equal to 0, right? So this means that x equal to what? X equal to negative, right? Negative 4/5, right? No. 5/4. 5/4, yeah. Okay, that's right. Negative 4/5. Okay. Why we need this point? Because as I said in the first lesson, that the curve changes shape at the point where the derivative is 0 or derivative does not exist. So at this point, the derivative is equal to 0. That's what we're interested in. And why we need x equal to 0? Because at which the derivative does not exist. When x equals 0, this one does not exist. So those 2 points are we are interested in. Okay, then second derivative. Second derivative is the derivative of this function. And to save your time, let me summarize this one by writing this out, which is equal to 1/9 x to the power of 2/3, 10/x minus 4/x squared. Let me see, is it correct? Okay. Well, it's nothing complicated, just find the derivative of this function and simplify, you get this result. And then this one equals 0. This never be 0, right? Because x cannot be negative. X negative is not, x equals 0 is not defined. So, but with is not defined when x equals 0, right? Also, this one equals 0. When x equals 0, the second derivative equals 0 means this line equal to 0, right? This 10 of x minus 4 of x is equal to 0. So from which that x could be found, x is equal to 5 over 2. You solve this equation, you get 5 over 2. Right? Let me do that a little bit. 10x minus 10 minus 4x equal to 0, right? X equal to 10 over 4. Yeah, that's correct. Alright, simply solve this equation, you get this. Alright, so we found these 2 points at which the second derivative equals 0 or second derivative does not exist. But these 2 points give us some kind of clue in curve sketch. Alright, so let's see. Lay out the picture by summarize the information into these intervals. X. How many points? 1, 2, 1, 2, 3. 3 points. 1, 2, 3. The first point is minus 4 over 5. The second point is 0. And the third point is 5 over 2. And divide the whole interval into 4 intervals. 4 intervals. Minus infinitive to minus 4 over 5. Minus 4 over 5 to 0. From 0 to 2.5. 5 to 5 over 2 over 5 to infinity, positive. Alright, then we have the first derivative, then we have a second derivative, then we have the shape of the curve, y. Okay. Now then we discuss interval, right? Interval. At 0, the derivative does not exist. The second derivative does not exist. And we calculate by plotting a number between this interval into the first derivative, and we get positive, 0, negative, positive, 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 negative, 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 0, positive. Well, this is just straightforward by checking the sign of the derivatives for each interval. I think we have done before. We don't spend time for that. Now, finally, for sketching the curve, we get the shapes for interval by interval, piece by piece. So here, the negative, positive. Negative, positive. Negative, positive is this shape. So this shape. And negative, 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 negative. Negative, negative is this shape. And the negative, positive is this shape. And the positive, 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 positive is this shape. Okay. So this is, these little 2 graphs is like serving as dictionary or Bible. Okay, then we find the location of this point. When x equals this number, we plug the number here and we can find a y. Right? The number is 1.034 roughly. And when x equals 0, y equals 0, right? It's 0. When x equals to 2 or 5, we plug in this into the function value, so we can find which is 1.303. Okay, these are preparatory work for your sketching the curve, right? And obviously we know that this increasing, decreasing, this is maximum. Or simply by checking that second derivative negative, first derivative positive is 0, is maximum. Here, the function does not, the function defines, but derivative does not. Because the left-hand side gradient is not equal to the right-hand side gradient. The gradient has to be, both sides must be equal, then the derivative is defined. And here, this increasing and increasing like this is the point inflection. Okay. That's it. The derivative does not exist, right? The function, it does exist. All right, then we sketch the curve by joining these pieces of information. First point is minus 4/5. The point is 1 point something. This is 1 point. This is 1, 1. This is 1. And at a 0, 0. And 2/5. 2/5 here. 2/5. 2/5. X is somewhere here. 1 point something. 1.3. 1.3 is a little higher. Then we join these points by a smooth curve. From infinitive to this point is this shape. It goes like this, right? See? From infinitive to this point. And then slowing down to this point. Well, has to be here. This is the maximum. Then change the shape into this. Then point inflection. Wow. Nice curve. Very good.